Hello class. Today I'm going to show you how to model real-world applications using the vertex form of the quadratic equation or parabola. As you see here in this chart, we have 5 examples of real-world situations, applications, events that can be modeled with a quadratic equation, or what we call a parabola. So what we will do is we'll use the vertex form of the quadratic equation to do that modeling. And the main point is that the vertex, these are the vertexes of the quadratic equations, which are modeling these different events or projects. And what we want to do is find the location of these vertexes relative to the origin, which is where x equals 0 and y equals 0. And knowing that difference will help us to do the modeling that we seek. As an example, this parabola here is right at the origin, meaning the vertex is right at 0, 0. X is 0 and y is 0. So when this parabola opens up, it starts at the origin. These other parabolas are at different locations relative to the origin. And so what we primarily are looking to do is to find out how far to the left and how far to the right have these parabolas been shifted, and how far up and how far down have these parabolas been shifted relative to the origin. For example, this parabola, its vertex, has been shifted up 8 units from the vertex, and it has been shifted over 8 units to the right from the origin. So that sort of information will be used to help us to utilize the vertex formula, the vertex form of the quadratic equation, to help us to model these various applications of the quadratic equation. So if we just look here, we have a project where we're trying to model the design of the width of a driveway. That can be modeled with this shape of a quadratic equation, or what we call a parabola. Here we have business profits in millions of dollars. That can be modeled by this type of a parabola. Here we have the pendulum arm speed in feet per second. So the speed of a pendulum, its arm, when it rotates back and forth. That's what's being modeled here. Here we're actually modeling a long jumper. When he or she jumps, they jump a specific height and distance. So that's what's being modeled here. Here the temperature is being modeled. So we have these different types of events or projects, activities that we want to model with the quadratic formula. And the particular type of quadratic formula that we're using is called the vertex form of the quadratic equation. And again, what we're trying to determine is, when we look at these various vertexes, how far are these vertexes from the origin, and the origin is here, meaning how vertically, how different is this vertex from 0. And you see that this vertex is minus 14 from 0. It's also 16 units to the right of x equals 0. So those are the things we're going to be looking for. This distance here, the vertical distance, when we go to our formula, that vertical distance is going to be called k. And the horizontal distance is going to be called h. So we're looking for, in this example, a vertical distance of 16, that's k, and a horizontal distance of minus 10. Okay, so let's go back up to the formula and see just what this vertical form of the quadratic equation looks like. And you see that it will be very, should be very simple to solve these types of equations. So here's the form. It says what we're trying to do is, for each real-world application of the quadratic equation shown in the charts below, derive and write the vertex form of the quadratic equation y equals a times x minus h squared plus k. And as I was just showing you, the h value represents the distance, the horizontal distance from 0, and k represents the vertical distance from 0. And as we have shown, it's pretty easy to find those values of h and k. Once you find them, you stick them in here, and that's the equation. And given the value of a, you can use GMath to chart that, and you're pretty much done. Except that we want to show these things also, but given that you know what the value of h and k are, you can find these other items very quickly also. Once we write the quadratic equation in the vertical form, then we want to write the coordinates of the vertex. And the vertex is just the the starting point of each of these parabolas. So the vertex is where the parabola starts, and again, parabola and quadratic equation or quadratic function are the same thing. And so when we ask for the coordinates of the vertex, we're talking about the starting point of the parabola. And those coordinates are just the x and y values here. So the coordinates of this parabola is minus 10 and a plus 16. So the x value, so would be v, and the x value is minus 10, the h value is 16. So if we go back here, you see, to find the coordinates of the vertex for the particular application that we're looking for, it's pretty simple. It's just v, and whatever that horizontal distance is from the x-axis, and whatever the vertical distance is from 0, that's what the value of k is and the value of h is. Then what we need to know is write the axis of symmetry for the equation. And the axis of symmetry is always where x is equal to h. And this axis of symmetry is the line that cuts through the parabola right at the center. So let's go back and look at that. Remember we said that h is the horizontal distance from the vertex to the value of x where x is equal to 0. So if we go to the vertex, that distance there, that h, always is the line that cuts the parabola right in half, such that on each side of this line, the parabola is a mirror image of each other. That's why we call it the axis of symmetry. So once you have the h value, which is the distance, which is the horizontal distance from x equals 0 out to the vertex, that distance represents the axis, represents the h value or the x value equaling the line that cuts the parabola in half, perfectly in half, so that you have a symmetric symmetry on both sides of that line. Okay, so that's what the axis of symmetry is, and that's why we say that the axis of symmetry is at x equal h, because when we go out h units horizontally, it goes right to the vertex, which cuts the parabola right in half. And then finally, the last thing we need to know is write whether the application has a minimum or maximum, and what the minimum or maximum value is. And then we say here the vertex coordinates VH of k is a maximum if a is less than 0 or if the parabola opens downward. The vertex coordinate VH of k is a minimum if a is greater than 0 or the parabola opens upward. So let's go look at that. You can see that if the parabola opens downward like this, meaning here's where the parabola starts, and if it opens downward going down, then the vertex must be a maximum, because it's the highest point of the parabola, and that highest point is always at the value k, which is, remember, the vertical distance from 0. So if your parabola opens downward, which is also when you have an a value which is negative. Let's go back and see what that a value is. So if you have an a value here, that's like a -2, -10, whatever, then your parabola is going to open downward like this. And when your parabola opens downward, which is having a negative a value, the highest point on the parabola is always at the vertex, and that height is always equal to k. Okay. Conversely, when the parabola opens upward, and that's if you have a positive a. So if a here is positive, like, you know, +1, +5, +10. So whenever you have a positive a, or whenever you see that the parabola is opening upward, then you know that you will always have a minimum at the vertex. And here are some other parabolas that open that open upward, and the vertex is a minimum because it's the lowest point on the parabola, And the value of that minimum, again, is equal to k, where k is the distance from 0 to the parabola. In this case, k is positive, and it's a minimum. In this case, k is negative, where we see the minimum. So whenever the parabola opens upward, the vertex is going to represent a minimum, and the value of that minimum is always equal to k, and k always reflects the distance from 0 to the value of the vertex. Okay? So those are the things that we need to do for each one of these parabolas that are modeled as a real-world application. And what we're going to do now is look at, I'll show you how to actually solve one of these. We're going to look at the driveway design width. The width of a driveway. We can model that with a parabola, and we're trying to find out what is the minimum width of the driveway. Okay? And so here I have an example. I've already sort of worked this out. And so we can see that the first thing we need to do is find the vertex form of the quadratic equation. And that general form is y equals a times x minus h squared plus k. And in this case, we know that we're given that a is equal to 2. So we go ahead and put the 2 there. And now what we need to find out is what is h and k. So let's go find out what h and k. And remember, h represents the distance from x equals 0. So the shift either left or right from x equals 0. And k represents the shift vertically either up or down from 0. So all we have to do is go find the parabola or quadratic function that's represented by the driveway design, see how far it's been shifted horizontally, see how far it's been shifted vertically, put in those values for h and k, and we're done. Well, as you can see here, I've done that, but let's actually go to the graph chart and see what h and k are and see how we got these values. So if we go back up here, this is the driveway design width in feet that's being modeled here. And if we look at the vertex, here is the vertex, and we see that the vertex is 5 units away vertically. It's been shifted up 5 units. So k has to equal 5, as you can see there. So that's how we got our value of k. We go, when you find the event or situation or project that you're trying to model, go straight to the vertex, look at how far the vertex has been shifted up or down from 0, and that becomes your k value, and that's 5. Then we look at how far the vertex has been shifted either left or right from 0. And here it's been shifted left, minus 18 units. Okay, so our h is minus 18 and our k is plus 5. So if we go back to our equation, you see if we put a minus 18 in here, the minus, and then the negative 18. I keep saying minus 18. You guys keep telling me I'm supposed to say negative 18. So the negative 18, which is h, and that minus sign makes that a plus 18. K is equal to 5. So we put that there. And we've been given that a is equal to 2, and so there, we're done. That's the vertex form of the quadratic equation. Next, we need to find the vertex coordinate. Okay? And we know that the vertex coordinate is minus 18 and 5. So x equals minus 18 and k equals 5. Let's just go back and look at that again. So we just go right to where the vertex is, and we see we go up 5 units, k is equal to 5, and we have to go over h units, and that's 18 minus 18 units, and so that's why our vertex is minus 18 and 5. Okay. Then what is our axis of symmetry? Remember, the axis of symmetry is the value of the line at x that cuts the parabola right in half. So how far over do we have to go from x equals 0 to get to the point where we cut the parabola right in half? And we have to go over minus 18 units, as you'll see here. So if we're at the 0, 0, how far over do we have to go until we get to the point where we come to a line that cuts the parabola perfectly in half, so that we have symmetry on both sides of this line, meaning that the parabola looks and acts the same precisely on either side of that line. And this is that line, x equal to 18, minus 18, which is also the value of h. And that's why we have that there. The axis of symmetry is x equal h, which equals minus 18. Alright, so in step number 4, we see that a is greater than 0. And since a is greater than 0, we know that the parabola opens upward. And if the parabola opens upward, then we know the vertex v h of k, which is v minus 18 and 5, is a minimum, because if the parabola opens upward, we know the vertex is represented by a minimum, and in this case that minimum is at the value of y equals 5. So again, we can go look at that. You can see just by looking at this graph, the lowest point on this graph is right at the vertex, and that value right at the vertex is equal to k, or y equals 5. Again, if we had a parabola that sloped down, we wouldn't have a minimum. There is no minimum, but we would have a maximum, and that maximum, or the highest point on that parabola, would be the vertex. Okay? And now finally, what we want to do is, now that since we have this formula, the vertex form of the quadratic equation, we want to take this quadratic equation in the vertex form and graph it. So what we do is we use GMath, and we put this equation in there, and then we're able to graph it. And that's pretty much how we do all of these problems. And so you can see I've left space for you to do all the other applications or types of projects that are being modeled by those parabolas. And then I've created 5 more examples of how we can model parabolas with the vertex form of the quadratic equation, and I've left space for you to go ahead and complete the information that's required to show that that you can model those, fill in those blanks, and then also use GMath to graph those. Okay, so you should go ahead and work on those. I'd like for you guys to work together, help each other out, and I'll be coming around the room to help you also. When you finish this assignment, remember to hit the turn-in button. You should be able to finish this during class. If you finish early, what I'd like you to do is to get started on the homework. And let's see here. The homework is this assignment here. Let's see, it says quadratic function and transformation homework. And I made that due, that's going to be due Monday. I know I assigned it either Tuesday or Wednesday. I believe I assigned it Wednesday. But we're just getting to the point where I feel comfortable that you have the skills to actually do that homework and graph it using GMath. So when you finish this assignment for today, go ahead and get started on that. If you need any help, I can help you. Hopefully you guys will be able to turn that in Monday, and maybe we'll have a quiz on this topic Tuesday. Possibly Monday, but I'm thinking more than likely Tuesday. All right. Thank you.